So the first example here, solve this quadratic equation by undoing so you can find the roots or the zeros of the equation. So we have example A, x squared equals negative 81. To undo that, we're going to square root both sides. Don't forget the plus or minus in front of that square root. Now the left side will just become x. On the right side, notice I have a negative 81. I can't go negative 9 times negative 9 because that would make it a positive 81. So I'm going to erase that and keep it as negative 81. Now here's the problem right here with the negative. This is a complex or an imaginary number. So we're going to remove that negative and replace it with the letter I out in front. And then everything else stays as it is. The 81 will stay underneath, plus or minus, and then our x. So our final answer then is x equals plus or minus I square root of 81. Oh, I need to figure out what the 81 is as a perfect. X equals plus or minus I. 81 is 9 times 9. So x equals plus or minus 9I. Let's come over to the second example. We want to undo. So I'm just going to rewrite the equation again. And I'm going to undo the 90. So I'm going to subtract 90 from both sides. So I get 5x squared. The 90 and negative 90 will cancel out. On the right, you're left with 0 minus 90 is negative 90. Ask yourself what would be the next step to undo. Well, that should be divide both sides by 5. So we're dividing both sides by 5, so the 5's cancel. We're left with x squared equals negative 90 divided by 5. I'll go ahead and divide that. 90 divided by 5 is 18 with a negative. And now we're going to undo the square. So we're going to square root both sides. So we're left with on the left x equals plus or minus. Now here's that negative that pops up. So I'll replace that with an I out in front. And then 18 stays underneath. And I'll break down 18. 18 can be rewritten as 9 times 2. And then the square root of 9 is 3. So we have 3i. And then this square root of 2 has to stay underneath.